Hello everybody, welcome back to another Miss Pollard Math YouTube video. Today we're going to be going over exponent rules, but more specifically the quotient rule. And the most important part about this first to understand is what is the quotient rule? So first, what is quotient? Quotient means division. It's another fancier way of saying division. So we're thinking about when we have our exponents and our bases and our coefficients and everything in the form of a division problem. What are our steps going to be? So our steps are to divide the coefficients if they're not evenly divisible, or what I mean is if we divide them in our calculator and they're not an integer, then we're just going to simplify that fraction, which we're in 8th grade now. We're able to simplify that fraction like pros, so that's great. So I either divide the coefficients if it's an integer value, or I'm going to simplify my fraction. And then I subtract the exponents. Subtracting the exponents, though, only works if they have the same base. So if they don't have the same base, you can't subtract their exponents because that's not correct. So there's a little dance that I like to introduce to my students to remember this rule. So it's a division problem. So we divide our coefficients, subtract our exponents. And you could put a little bit of pizzazz in it. Divide, subtract. Some of my students like to divide, a little dab in there, whatever gets you to remember our rules. So we divide and subtract. So let's try a problem and put that dance into effect. So we have this problem, and look at all those wild variables and coefficients and bases and everything. We're like, what am I going to do here? It looks scary at first, but let's break it up what we have to do. So we're dividing our coefficients. Our coefficients are the number in front of our variables. So our coefficients are going to be the 30 and the 15. I like to box off what I'm working with. So I have 30 and 15. I do my little dance. My dance tells me to divide. So I do 30 divided by 15, which is 2. I divided. Now my second part is to subtract. So I'm going to subtract my like bases exponents. So I have a w to the 9th and a w. I like to put them together so I know I'm working with that. We have to recall that w has an exponent of 1. There's a exponent on that variable. So it's 1. You can put that in if you need to. We eliminate the 1 because it's more mathematically correct. We don't say I have 5 to the first power apples, something like that. So I'm going to do subtraction. 9 minus 1 is 8. So w to the 8th power. Let's now do it with the x's. So I put them together. 14 minus 8 gives me x to the 6th power. Then I have 9 and 2. 9 minus 2 is 7. Y to the 7th. All right, z to the 11th and z to the 6th. 11 minus 6 gives me z to the 5th power. And do we see how all of these are in our numerator? Because technically 30 divided by 15 is 2 over 1, right? But I'm not going to put a divided by 1, because that's a little bit cringy. I'll put the 5 here. I don't know why I floated it all up there. Put the 5 there. So we have 2w to the 8th, x to the 6th, y to the 7th, z to the 5th as my final answer. I have no denominator because none of the exponents of our variables are bigger than the ones in the denominator. So none of these ones down here are bigger than our numerator ones, so they stay in the numerator. If, let's say, our exponents were bigger in the denominator, let's say this was flipped, and the 9 was in the bottom, the 1 was in the top, it would remain in the bottom. Wherever it has the most amount of variables, that's where it stays. But we're going to see this in my other video, my exponents of negative exponent ones, because if you subtract them, it'll give you a negative. I'm not going to spoil that video, so go watch that if you have some negative exponents. We're going to stick with our positive exponents for these problems. Let's take a look at another problem to make sure we're fully understanding this topic. Now I have this problem, and I have my coefficients of 25 and 10. If I divide 25 by 10 in my calculator, I get 2.5. 2.5 is not an integer value, so I can't just put 2.5. We don't leave it as a decimal. We leave it as a simplified fraction. So I have 25 divided by 10. What is their greatest common factor? Their greatest common factor is 5, so I'm going to divide a 5 out of both of them. So 25 divided by 5 gives me 5 in the numerator. 10 divided by 5 gives me 2 in the denominator. So I'm just simplifying it simplifying my fractions like you would have saw in prior years. So I divide or simplify and subtract. So now I'm going to subtract my liked basis exponents. So I have x to the 5th and x squared. That becomes x to the 3rd. There's more in the top, so I leave it in the numerator. I have y to the 3rd. We were like, wait, Miss Pollard, there's no y's in the denominator. You're right. So what am I going to do? There's not much I can do. There's a y to the 3rd and nothing in the denominator, so I leave it as is. It's still going to be part of this problem. So I have y to the 3rd still there. And now I just continue like normally. Z to the 35th and z to the 15th. I subtract 35 minus 15 gives me z to the 20th. During class, we went through breaking it up and having to cross out from the numerator and the denominator. Why waste our time doing that when we just know the rule of subtraction? Let's try one more problem and make sure we're fully getting this. All right, so we have our last problem here with all of these different variables and all this good stuff. So my first step, once again, is to divide or simplify whatever I can do in that case for my coefficients. So I have 18 divided by 4. If I put that in my calculator, that is not an integer value. So I have to simplify. I have to take out my greatest common factor. Between 18 and 4, the greatest common factor is a 2. So I'm going to divide both by 2. So 18 divided by 2 is 9. 4 divided by 2 is 2. So I have 9 over 2. Now let's get moving. I have b to the 15th and b to the 9th. So I circle them. 15 minus 9 is 6. So I get b to that 6th power. I subtracted those exponents. So b to the 6th power, I'll move this so it looks a little bit easier. B to the 6th power. Now I have c to the 4th and c once again. That's a 1. So 4 minus 1 gives me 3. So c to the 3rd power. Then I have a d to the 7th. Once again, like we saw before, if there's something in the numerator and nothing to go with it, not a like term in the denominator, we leave it where it is. So I'm going to leave it as d to the 7th. We haven't seen something, so I already did it. I'm going to cross it out so I remember I already wrote it. We haven't seen something where they're the same in the numerator and the denominator. It could be e to the 5th and e to the 5th. If it's the same, they just cancel out. If there's one in the top and one in the bottom, they cancel out. Because it's like doing 1 minus 1, which is 0. Well, e to the 0 power, which you'll see in next week's lesson, is 1. So we're just multiplying by 1, which just means it's canceling out. Anything times 1 is just itself, so they just cancel out. They're gone. Just like we saw when we expanded. We crossed 1 from the numerator, 1 from the denominator. It's gone. So now I look. Everything's touched but the a to the 8th. So, what am I going to do with a to the 8th? Well, there's no a's in the numerator to go along with it. So I'm just going to leave it in the denominator as a to the 8th. And that's my final answer. So hopefully this helped us to figure out what we do when we're given a division problem and exponent rules. It reminds us that we have to use our divide and subtract rule, a nice little dance to go along with it so you remember what you have to do.